The piano itself is a very big and beautiful instrument. There are 88 keys on your typical piano. From all those keys, the very first note that as a beginner you learn to find is not the first one on the left, and it's not the first one on the right, but it's this one, right in the middle. And this note is called middle C. Not middle C++, unfortunately. We can't be everywhere. Now, once you learn middle C, you start to branch outwards from there. You start learning all the notes and where to find them, and you start learning how to read sheet music. And once you learn how to read sheet music and find the notes, theoretically, you can learn how to play any song. As a young learner, I asked myself, once you know how to play every song, what else is there to learn? Turns out there's a lot more, because in piano, it's also very important to have good technique. Good technique comes from things like good posture, hand positioning, and agility. All right, so once you know how to play and you have good technique, is that it? Well, one day, my parents brought me to the Toronto Symphony Orchestra, and I got to see a professional pianist perform. I realized that this pianist was compelling not just because they were technically excellent and hitting all the right keys, but because of the way they expressed the music. You could see their body moving with the music, and that performance and ability transcended just playing the music and turned it into true artistic expression. So how does all of that tie back into software engineering? Well, let's look at one of my very first projects. This is an interactive website that uses machine learning to recognize sign language and transform it into text. I made it using a very limited data set with a sample size of just one person, me. And when I tested it myself, it worked with 100% accuracy. But you might be able to guess what happened when I tried to change any small little thing about my environment. Even something as small as the sunset changing my lighting conditions severely affected my model's accuracy. Trying to have another person test it was even worse. When I started working as a data science and machine learning intern 2 years ago, I found the same problem. My computer vision machine learning models would work perfectly on me, and generally also for the type of people that were represented in the engineering team, because we were the ones constantly testing the model. But when we moved to beta testing volunteers, our accuracy went down. As AI and machine learning becomes more prevalent, I also hear more and more about how underrepresented groups like women, people of different races and skin colors, and people of different ages find it less effective. In machine learning, just like learning how to play piano, you also have to first orient yourself by gathering requirements. Then, once you know how to create a model, you can train a computer to do anything. And finally, you can optimize your model so that it works perfectly, at least on yourself. But it turns out that the one unique connection between making a great piano performance and a great machine learning project is that you cannot strive for only technical excellence, but also consider the humanity that drives it. Just like how piano artistry comes from a performer's own interpretation of the music, rather than just playing the right notes, machine learning products must be trained with unbiased data representing everyone as best as possible. It's only then that we can expect these products to work for all users. By creating a harmonious blend of technical skill and ethical considerations, we can compose a more inclusive and resonant future. Thank you.